The minute and hour hands of a clock are 15 centimeters and 10 centimeters long respectively. Find the rates at which the angle and distance between the tips of these hands of a clock are changing when the time on the clock shows 12:30 p.m. So the first thing to do, I am providing this picture of an empty clock to you so that we can actually draw the situation, draw the exact time to model the situation described. Okay, so we're talking about the minute hand drawn, the hour hand drawn from the center. So we can draw it using a straight line segment. So suppose this is going to be 12:30 for the hour hand. For the hour hand. And for the minute hand, we're going to be drawing another segment like this. And then to connect them, of course, the tips of these two hands, we will make it like this. Okay, so now, as you can see, we can label this as the D that we need to find. And the angle in question is going to be here, the angle between the hour hand of the clock and the minute hand of the clock, right? So we can label it as theta. Oh. Like this, theta. Okay, so now also we can label the clock hand's length, the length of the hour and minute lengths. So the minute length, the length of the minute hand of a clock is going to be what? It's going to be 15 centimeters because obviously the minute hand is longer than the hour hand. And the hour hand length is 10 centimeters. Okay, so as you can see, what happens is that we also will find out the angle measure in degrees that lies between the hour and the minute hands of a clock, right? We know that, we can calculate that. So if we know the angle, we know three sides, right? Basically the D side, the angle is known, and the two sides are known. You definitely are looking at the law of cosines, all right? So that should be clear, the law of cosines. So now, how do we write an equation using the law of cosines? Well, here's the thing. Recall that a squared plus b squared, so c squared is equal to a squared plus b squared minus 2ab cosine of c. Recall that. And c squared is the longest side in this case. So we will have to do d squared instead of c squared here because this is the longest side that represents the distance between the tips of these hands of a clock. And the opposite, the angle opposite of which is the longest side is going to be the c here, the capital C. Okay, so in this case we're going to do theta instead of c because that's the measure for the angle. That's the variable for the angle measure in degrees. So let's substitute. Now, before we go on, we need to understand that the d will change, right? The distance will change depending on the time, depending on the current time, because the distance always changes between the tips of these hands of a clock, right? Because if, let's say, the time is 12 p.m. and not 12:30, the distance between the two hands is the distance between the tips of these two hands is precisely 0, right? Because they're both showing at the same spot of 12, right? But here, the hour hand shows right in the middle between 12 and 1, and then the minute hand shows right at 6 here, right? So the distance here is a different distance than it is at different times, right? So the distance changes according to time t. So as a result, let's introduce the variable t. So we're going to say let t represent minutes from 12 p.m. Right? So 12 p.m. is going to be a very good reference. So we're going to start the countdown from 12 p.m. And we know that we were talking about basically 30 minutes precisely, right? Because if we start the count from 12 p.m., we will have gone 30 minutes, right? So as a result, we need to find, the question asks you to find what? It asks you to find the theta of theta prime of 30. Now why prime? Because it's talking about the rate at which the angle between these two hands of a clock is changing, right? The rate, right? So the rate means that you're talking about a derivative, right? So that's why it's theta prime of 30. And the question also asks you to find the distance, right? The variable distance d. So you're talking about d. So let me put this in blue. And the d prime, of course, d prime of 30 as well. Okay? So this is a question mark. So these two are what we need to find. So now in order to find them, you need to actually derive some kind of equation involving the t and involving obviously the theta and the d before you take the derivative, right? Because in order to find the derivative functions, you need to actually find the theta without the derivative, right? The actual theta as a function of t, or the d as a function of t. As you can see, since we talked about the law of cosines, you're obviously going to find the function for the d as a function of t, right? Not the d prime, but just the d. It's going to be easier. So what is the law of cosines? Using this, what I've written here, c squared is equal to a squared plus b squared minus 2ab cosine c, we can change the c squared and let it be d of t. Okay, so we're going to put d of t, and we're going to square that because d takes place of the c, right? So d squared is equal to a squared plus b squared. Now here you can be flexible, right? You can name the a or b in whichever way you want. You can name your a being 10 or a being 15, right? Whichever one you assign, it's going to be fine. It's not going to change the result. But I'm just going to assign 15 as the a. So what I'm going to do, I'm going to write 15 squared plus b squared, so it's going to be 10 squared, minus 2ab, so minus 2 times 15 times 10, cosine of what? Cosine of c. Now c is what? C is the theta, right? So cosine of theta. Okay. Now theta of t, right? Let's not forget that, because that also varies by t, right? The angle always varies, just like the distance between the tips, it varies as well. So cosine of theta of t, so let me put brackets there too, like that. Okay, so now that we found that, let's actually simplify that. Let's actually simplify this and see what we get. So as a result, let's find d dt squared is equal to this, right? 225 plus 100 minus 300 cosine of theta of t. Theta of t. Okay, so now that we found that, let's actually so remember that in order to properly use the derivative, right, if you're gonna use implicit differentiation and differentiate both sides with respect to t, you will have to find the distance at the time of 12:30 p.m., right? So you will have to find this d value, because at theta, there's a certain theta value, the certain angle measure at 12:30 p.m., and you will have to find the d as well, right? But let's actually find the derivative first. Let's differentiate both sides implicitly first. So differentiating the left side, we would get what? We would get 2, right? Because the power rule says that the 2 comes down first, and then we're going to differentiate the inside. So the 2 d of t times the derivative of the inside, which is going to be d prime of t. So d prime of t. And the right side is what? Differentiating with respect to t. These are constants, so they turn to 0. So 0, 0. And this one is what? Minus 300. Now so this is a constant that's untouched. Now, first we differentiate the outside function. The outside, the derivative of the cosine is minus sine, right? The negative of sine. So we're going to say the negative of sine of theta of t. We didn't differentiate the theta yet. And now we're going to differentiate the inside, which is theta prime of t, right? Theta prime of t. So let me close that. Theta prime of t. Okay, theta prime of t. Okay, so that's that. Okay, so now that we got that, let's actually make this even simpler. 2 d of t times d prime of t, and I really want to use these colors, so be patient, just so to make it easier, because this is not an easy problem. So this will be what? This will be positive, right? So positive 300 sine of theta of t times, of course, theta prime of t. Theta prime of t. So as you can see, this looks a little bit simpler now. So here you go. So you just found the derivative using implicit differentiation. So what are you going to do next? So you obviously, in order to find the d prime of t, you have to find the sine, you have to find the theta of t. Well, t is equal to 30 in this case, right? Because we're talking about 30 minutes. T represents the number of minutes from 12 p.m., right? So theta of 30, so you're going to substitute 30 in here. So let t be equal to 30. So when t is equal to 30, we can find the theta of 30, right? We can find the time. The theta of 30, how do we find that? Notice that this is exactly 15 degrees between 12 and the midpoint between 12 and 1, right? So the hour hand at 12:30 p.m. is right in the middle between 12 and 1. And we know that from 12 to 6, there's 180 degrees, because we're talking about a diameter of this clock, 180 degrees. And every 5 minutes is exactly 1/6 of the 180 degrees in angle measure, in degrees, right? So that's going to be 30 degrees. 1/2 of that is 15 degrees. Okay, so we know, so if we subtract 15 from 180, we will get the theta angle, right? So that's going to be 180 minus 15, which is 165 degrees. So we found the theta of 30, that's good. And now we need to find the distance. Okay, the distance of that. Now to find the distance, of course, you would use the law of cosines to find it, right? So the law of cosines. So how do you do that? So you have to square root both sides of this equation, right, in order to find the distance between the tips of these two hands at t is equal to 30. So let's see. So the d of 30 is going to be the square root of this. And we already found the theta of 30, so we're going to find the cosine of 165 degrees. So we're talking about this. 225 plus 100 minus 300 cosine of 165 that we found. Theta of 30, 165. Now this is in degrees, so be careful that you include that. So what is that going to be? That's going to be 24.794 7121 centimeters. So that's the distance that we found. So now we found pretty much, did we find all components? Well, almost. So now what is going to be the theta of t? How do you find the theta of t? So in order to find theta of theta prime, you will need to derive a theta of t as a function of t, because otherwise you can't find the theta of prime. Right? So we need to find theta of t. Now theta of t will depend on the time, right? Because the angle will change depending on what the hour is doing and what the minute is doing. So to do that, you have to realize that the angle will be the difference between the minute hand and the hour hand. Okay? Now how did I arrive at that? How did I arrive at this? Notice that the minute hand travels faster than the hour hand, right? So in 30 minutes, look how much the minute covers. It covers 180 degrees, right? From 12 to 6. But in 30 minutes, the hour hand only covers 15 degrees, right? So we need to find the m of t and the h of t. That represents the number of degrees per t minutes for the minute hand and the hour hand. So let's find that. The minute hand is going to be what? You know that it covers 360 degrees per 1 hour. And then 1 hour takes 60 minutes. And then multiply that by t minutes. Multiplied by t minutes. You will have crossed out the hours, the minutes, and only will have the degrees as a function of t. Right, so this is what? This is equal to 6t. 6t degrees. Okay, this is 60 degrees. And h of t is equal to what? We know h covers 360 degrees in 12 hours, right? We said that the minute hand covers 360 degrees, one full circle, in 1 hour, right? The minute hand. But the hour hand goes from 12 to 12 in exactly 12 hours, right? Because it's talking about hours for the hour hand, so 12 hours. So 360 degrees per 12 hours times the hour taking 60 minutes times the t minutes. So as a result, this is equal to what? This is equal to, the minutes cancel out, the hour cancels out. This is equal to 1/2 t, right? Because 360 divided by 12 is 30. 30 divided by 60 is 1/2. 1/2 t degrees. So what does that tell you? That tells you that the theta of t can be now found. So theta of t is going to be now what? mt minus h of t. Mt is this, right? 6t degrees minus 1/2 t degrees. Which is what? Which is going to be 11 divided by 2, right? So 12t over 2 minus 1t over 2, 11/2t, 11t over 2 degrees. So now you can safely take the derivative. The only thing is, if you take the derivative, you have to make sure that you are in radian mode. When you take the derivative of the angle, make sure that you're in radian mode. So to do that, you have to convert this to radian mode, right? So how is this going to be in radians? This is going to be 11 over 2t times pi over 180. Right? This translates from degrees to radians. So as a result, this is what? This is going to be 11 pi over 60. 11 pi over 60t. So now we know, based on this work, that we can find the theta prime of t, because we already found the theta of t, which is 11 pi t divided by 360. So theta prime of t is going to be easy, right? It's just going to be the constant in front of the t. So 11 pi over 360 radians per minute. Okay, so now that we found theta prime of t, we know that anytime you pick, the theta prime will always be 11 pi of 360. Okay, so theta prime of 30, for example, the angle, the way the angle changes, the rate at which the angle changes will remain 11 pi over 360 no matter what the time you're talking about on the clock. Right, so that's always going to be a constant quantity, 11 pi over 360 radians per minute. Okay, so now that we have that, we can use this equation here, 2 dt times d prime of t is equal to 300 sine theta of t times theta prime of t. Now, we also found out that the distance at 30 minutes after 12 is going to be 24.794, this d value here, the distance. And so what do we need? We need to use the equation and actually solve for d prime of t here, right? So we're going to use this equation and solve for d prime of t. And notice that what we found just now answers the first part of the question, because we found the rate at which the angle between the hands of a clock is changing. So that's one part. Now the second part is to just find the d prime of t, which is the distance between the tips of these hands of a clock. So if we rewrite this and solve for d prime of t, and let's already plug in d prime of 30 because that's what we need. So we're going to do d prime of 30 is equal to this thing, 300 sine Now, theta of 30 was what? Right here, right? So theta of 30 is 165 degrees. We found that. So let's solve. So 300 sine of 165 degrees, because that's the theta of 30. And then theta prime of 30 will be the constant. So 11 pi over 360. And that has to be divided by twice the distance at 30. Now, twice the distance at 30 is what? So twice the distance at 30, which is 24.7947121, right? So 24.7947121. Okay. Notice right away that 300 divided by 2 can be simplified. So we can actually get rid of 2, and we can get rid of 300. And we can write this 300 instead 150, right? That will be easier. So we can just write 150 sine of 165 degrees times 11 pi over 360 divided by 24. All right, and if you do this carefully using your calculator, the answer that you should get is this: 0.1503 03286, 03286, which is about to 2 decimal places rounding is 0.15 centimeters per minute. And centimeters because we're talking about the distance, right? The distance, this d value, how fast this d value changes, right? And that's going to be 0.15 centimeters per minute. And notice that it makes sense, right? Because distance is changing really, really slowly here, this d. Because basically what the 10 and 15 are doing, they're getting closer and closer to be on the d itself. Because the angle is increasing. Because as we get closer to 1 p.m., you know that there will be a point at which the hands of a clock will be at a straight line segment, right? So they will be basically the d. So the distance between the tips is increasing really slowly at the moment when it's 12:30 p.m. right? And as you can see, it's really, really small, only 0.15 centimeters per minute. So I hope this was helpful and fun. Thanks to you so much for watching, and I'll see you in the next video.